Yeah, unfortunately it's one of those.
We're all
mortal, aren't we?
yes. I'm
So,
afraid.
if I can just get you to start off by telling me your name
Okay.
and just talking about how you got interested in space and where
Right.
you went sort of education-wise up to the point where you started your career.
Yeah. Well, I can see where we start that. Since I had to do this now. Okay. Am I right? Is the sound okay?
You're fine. Yeah,
Okay.
no, it's absolutely fine. Perfect.
Yeah. Okay. All right then. Hello. My name is Bob Parkinson. I've been involved in the space business for too long now, and I first became interested in space as a youngster, I suppose, in the 1950s. Partly due to the Eagle magazine, which influenced an awful lot of my generation, and we all wanted to fly to the planets, and also books by people like Arthur Clarke and so forth, and people who produced picture books. There was two big things in the 1950s. One came from America, where an artist called Chesney Bonstall wrote a number of books with von Braun and Willy Lai and people, and one from the British Interplanetary Society, basically, where they had an illustrator called Ralph Smith, who produced a series of paintings that Arthur Clarke wrote text to, and that set me on my way, as it were. And in fact, there's one sentence in that particular book, The Exploration of the Moon, that probably influenced me. I went off to university to do engineering, which my grandfather basically influenced me because he was in this line. But in Ralph Smith and Arthur Clarke's book, there was one sentence I remember which said, and the people who go to the moon will all have PhDs or something of that nature. So I decided I needed to do postgraduate work. So I having done my first 3 years to get a BSc at Nottingham, I then stayed on for another 3 years to do a PhD. And at the end of that time, there was a question about what to do next. And for some reason, it was the wrong time to be a space enthusiast. The UK was not really interested in space. Some of the adventurous things that had been going on were about to collapse. There didn't seem it was difficult to say what would be going on there, but I decided to look at the Scientific Civil Service. And in those days, getting a job was easier than it is today, because essentially I went round and interviewed people. I went to Farnborough and their outstation at Bedford on Winters. I went to Boscombe Down and I went to Westcott. And in my interview at Westcott, they had a group there who were working on liquid hydrogen for space propulsion, and that was it. So that's what I said. That's what I'd like to join that. So I came to Westcott originally in what date was it? 1965. Yes.
Yeah. Do you want to start that sentence again? Just say, I came to Westcott.
Okay. I came to Westcott in 1965, basically to work on their work on liquid hydrogen. Joining a group led at that point by Barry Ricketson, who had been playing with liquid hydrogen for space propulsion. They had had they did been part of an investigation to put a liquid hydrogen stage on top of Blue Streak to make a satellite launcher in those days. And I joined that group to do further work towards this. Unfortunately, the impetus was losing, but there was a European project that had started, the European Launch and Development Organisation, ELDO, that was looking at the possibility of a European launch vehicle. It was an interesting group. I'd not sort of met this particular group of people. That particular group was working in building 276, which was away from where a lot of other action was taking place. And when I first worked there, I wondered about this group, because they'd come in about 9 o'clock in the morning, put on the coffee pot, sit around talking, eventually go away and do something, come back at 11 o'clock for another coffee, and so forth. And I did kind of wonder about whether they ever got any work done until I discovered this was really the Tiger team. This is the group that had been given the difficult jobs and so forth. And they did get things done. Getting hardware was difficult, but they'd already done a lot of work. And one of the things that was a source of concern and that I recognised there because of what I'd done earlier in my PhD was the problem about calculating the heat transfer in a rocket engine. It's all about heat transfer. If you don't get that right, you wind up with a puddle of metal in about 2 seconds flat, and so forth. Is one of the things that's happened to me several times in my career is somebody has told me something I knew wasn't right. And I'd say, you're a load of idiots. You need, and this was one of them. If you look, in fact, still in the textbook, it tells you that you calculate heat transfer using a formula generated by an American called Bart's that says it's a pipe flow. And I knew that a rocket engine is not a long pipe. It's a short thing. The boundary layer is still developing, is going to be different. One of the nice things about this group, really without doing too much, was that essentially for the next year, that was my job. It was go and find out about how it works and do it. And I developed, we had data from our own firings, and there was a lot of American data and so forth knocking around. And so one of the first things I did was to take where we had heat transfer measurements and compare them with what Mr. Bart's formula said that the heat transfer should be, and plotted a chart that looks a bit like the sky at night with points all over the place. I think there was at least 2 orders of magnitude difference in the possible production. And so, we also knew, and the group had contacts with Imperial College, who knew a bit more about things, that there was other things, in particular a Russian approach that worked on a developing boundary layer and ought to give better things. And so what I did using the Elliott 503 computer, no, Elliott 803 computer, I think it was in those days, which was a massive thing which occupies its own air-conditioned building, and used and had 8K of memory, 8,000 words of memory. this tells you what we were working with, was to take the data, the measurement data, and compare it with the theory, and then look for systematic variations from the theory to see whether there were particular things that meant that points didn't fit the theory. And there are a number of things that came out. It was obvious that the basic boundary layer development theory was probably right, but it depended on things like how the combustion progressed in the thing. It depended on some of the data was on very small. In fact, there were some American data from JPL that was basically hot gas flowing in a very small nozzle. So that is a sort of different flow field to the sort of F1 engines on Apollo, for instance. And then there were other effects that came into in the chemistry and so forth. And one by one, I was able to isolate these particular features, getting better and better correlation until we were down to about 15% variation of the experiments from the theory, which was at least an order of magnitude anything. We actually put that work into by the late 1960s, the Rolls-Royce Val Cleaver's group had been developing or designing an engine that for this European launcher development project, and we actually put that into that. And in fact, while the computer program I wrote has long since been put on much bigger computers and all sorts of other things, I still have that as the basic thing when I talk to my students at Cranfield about how you design rocket engines, and that's it. We at the end of that day, partly due to one of the things that I got involved with the group, and those days there was a thing called the Aeronautical Research Council, which was a load of different committees that looked at problems across the field of aeronautics and propulsion and so forth. And there was a heat mass transfer committee, and I was put as secretary to one of these groups. But it also allowed me to put what I was doing in front of a wider audience. One of the people who attended that, who had practical experience in heat transfer, was one of the Germans we'd inherited after the war, called Hans Siebland. And in fact, out of that group and out of that meeting, Hans Siebland and I put together a book on heat transfer in rocket engines, which was the first real thing for basically for AGARD, which is the research end of NATO. So that was the first thing that I did.
Sorry, I was just going to say, this is brilliant. Can we just wind back a little bit and just talk a bit more about why Westcott was looking into liquid oxygen, liquid hydrogen,
right,
what the advantages were, what the problems and the difficulties, and why, because eventually I don't think we ever actually did, we never produced an operational.
We didn't produce, okay. This was all the hydrogen work was really all to do with the idea that we could have a European launcher. What eventually killed that was Wedgwood Ben deciding that he didn't want to continue contributing to this European launcher development organisation and pulling the UK out of it, which happened in 1969-70. The advantage was, which everybody knew, was that an oxygen hydrogen engine had a much better specific impulse, much better performance than the liquid oxygen kerosene of the first stage. But the problem is liquid hydrogen, which is that liquid hydrogen boils at 20 degrees absolute, minus 253 degrees. So you don't find much of it sitting in a puddle. And the objective of the group was to find was to find out all the problems. So we had and so one of the things we had to do was produce something that would produce liquid hydrogen. So one member of the group, Trevor Horton, was busy building a liquid hydrogen liquefier at Westcott that would produce liquid hydrogen for us. We had experimental rig at a site that was it didn't actually run on liquid hydrogen, because if you look at a hydrogen oxygen engine, by the time the hydrogen gets to the combustion chamber, it's not liquid any longer, but it's very cold. So we had a way of taking gaseous hydrogen, cooling it down to the right sort of temperatures and injecting it into so there was work going on combustion there. Later in the 1960s, we had work on that I got given put in control of, which was actually the problems of storing and putting it in tanks and so forth. So we actually built a small tank for liquid hydrogen, put it in a vacuum chamber because it wouldn't work any other way, and looked at filling it with liquid hydrogen and how long you can keep it, what happens to it. Does one of the problems you get with liquid hydrogen is that you may start off with the temperature or one temperature, and you keep it from boiling by putting the pressure up a bit, but then the warm hydrogen rises, the warm liquid gets to the top, and then some of the parts get unusable for that reason. That was actually useful in due course, because the rest, if you look at how things go together, for that job, the hydrogen tank and rig was being built by Hawker Siddeley at Stevenage. And so I got to meet and work with some of the engineers at Stevenage, and 20 years later, or 15 to 20 years later, depending where you start counting, I met one of the people who I'd worked with at that time, was now the deputy chief engineer there, and got a job at Stevenage when I didn't want the job in the scientific service any longer. So the connection was still there. We got to know one another and respect one another. And so, in fact, in the final days before we finally pulled out of Eldo, I was running an experimental rig to move and store liquid hydrogen that Trevor Horton liquefier was producing, and so forth. And we got involved in the work that Rolls-Royce were doing to produce the RZ20 engine there and provide things on that. So there was a lot of different things working. You have to worry about all sorts of things, like how do you know how much hydrogen there is in the tank? And I claim to be one of the few people in the world who's actually seen liquid hydrogen, because normally you see it, it's in a metal tank and you don't see it. But we needed to do some work on level sensors to work out where the liquid thing was, and for that we had a Dewar flask that was unsilvered, so that we could watch what the liquid looked like as the sensor hit the surface and so forth. So we did all sorts of bits and pieces there.
Can you talk to me a bit more about sort of day-to-day life working at Westcott? some of the people you're working with, and the sort of atmosphere of working there?
Well, that particular group worked quite well, actually, partly because we were sort of sitting by ourselves, and it had well, I think that Barry was a good boss to work for, because he didn't have a set program of you do this, you do that, do the other, but he would let people organise what they needed to do, and so forth. And he'd come from an academic background, and it was a bit like a university running a thing. So it worked very well from that point of view. And it wasn't a matter of 9 to 5 job either. I'm trying to think.
To be a bit controversial,
yeah.
those sort of academic university type environments tend to be a bit at odds with industrial type environments, don't they? And that's
it was sort of halfway in between, to some extent, but the important thing, I think, is that the people in the group were motivated. We all wanted to make this work. Our objective was to find out how things were. If you seemed to be making progress, you were encouraged. If you weren't making progress, then you need to. And occasionally, things would arrive in the group that you weren't, and people would take particular projects, as it were, on to do it. As I said, it was the job. It was the group that got given the difficult jobs, the jobs that weren't part of a set program. And so when those happened, you maybe dropped everything and worked. I got one of these things that, again, because of our association with the European launch vehicle business, it was Charles Martin at Stevenage who spotted the thing to start with. Originally, the thing had been designed, the Blue Streak had been designed for a silo launch for a ballistic missile. And if you get silo launch, then you've got to be, when you fire the engine, there's a lot of hot gas and pressure around the vehicle, so you've got to stress the vehicle a bit for what it's doing. They'd done the first Blue Streak launch out of Kourou in French Guiana, and there was some telemetry records that showed that the back end of Blue Streak had been subjected to some high pressure at the as they launched the thing, and he was worried about this, and he came to Westcott and said, because the group at Westcott had also been involved, my group at Westcott, before I joined it, had been involved with the underground launcher project for Blue Streak, and said, hey, we seem to be getting this, what's going on, and so forth. And I got given the job of finding out what was what went on here, and so forth. And we did a little bit of a panic where we built a scale model of the French Guiana launch site on its side, because you fired rockets and the thing went up in the air. And that was sort of drop everything and find out, because this could be serious. And that was what you did. That was interesting. There's it's interesting why why you get these overpressures when you're not in a hole in the ground. Everybody can see that if you fire a rocket in a hole in the ground, you're going to get pressure around. Why do you get them when you're not in a hole in the ground? The problem at Kourou, the original.
Sorry,
yeah, sorry.
I just shut those doors.
Yeah.
Yeah, sorry about that.
Right.
That's interesting actually, because I never realised that Blue Streak had been launched from Kourou.
Yes.
Oh right, were
Yes.
you there for that?
I didn't go to Kourou.
No.
The original place where Blue Streak had been tested as a ballistic missile was at Woomera, and the launch pad there was basically over the edge of a 90-foot cliff. So there was nothing underneath it when you fired it. You didn't have to worry about the flame or anything. At Kourou, it's a what do you call it? A littoral. It's a flat coastal plain, and the launch pad. I forget how far off. Raised it a little bit above the local scenery, but not very much. Maybe 5 meters or so. And the problem then was, there's your rocket firing downwards. You've got to get rid of that exhaust out the side in a very short space of time. So you have a launch deflector and so forth under the thing, and that confines the blast. And when you start it suddenly, that confines the build-up of gas, and that generates an overpressure, and some of that overpressure comes back at the rocket. And in fact, we discovered from other documents from Americans, because we'd been associated with General Dynamics, I think, on the Atlas, that they lost several atlases because of this, because the back end of the vehicle, where the rocket engines are, you don't want hot gas to recirculate in the engine bay because it tends to damage the pumps and so forth in that. So they put what's called a heat shield to keep the hot gas away. The Atlas people lost, I think, 3 Atlases at altitude, and they didn't know why. And it turns out that their launch pad that they've been doing had a even bigger constraint than the Eldo site at Kourou. We effectively turned into a corner and down a long tunnel. And so that allowed an even greater pressure. And what it was apparent was that when they first fired the engines, those had damaged the heat shield under the thing. But it doesn't show at low altitude. It's when you get to altitude that you get hot gas recirculating because the flame expands and so forth. So they got failures at altitude because of something that happened in the first second of launch. Once we sorted that out, that was and that allowed us to work out how to design the pad in French Guiana to reduce this overpressure that had worried Charles Martin. And it also, incidentally, gave me a slight a sideline in how you get flames round corners in a hurry. So that the rest of my career at Westcott, certainly, about once a year, somebody with some other problem from the military side would have problems in what do we do with the exhaust plume, and I'd get a trip to certainly out. I got one trip up to Kiruna because they'd been finding skylarks there and getting over pressures, and gave me a trip up there to work out what they were doing wrong that were giving them the overpressures.
You became the go-to man on that.
Yeah, when I eventually left Westcott, I gave Peter Penny, my successor, how you dealt with this problem in about an hour and a half things, because it was sideline knowledge that was just kept until you got a problem. It wasn't a long-term problem.
Can you just talk a bit more about the people you were working with at Westcott? Because I mean, it wasn't necessarily just.
I'm going to have a problem at this point because my memory for names is not always very good.
Well, I mean, but I know Alan Bond didn't.
Yeah, Alan came into this. Alan never worked for.
Can I just get you to say Alan Bond?
All right. Yeah. Because my history with Alan Bond is significant. One of these things that happens. I said earlier that we were working with Rolls-Royce at Anstey on developing rocket engines and so forth. And because they were building hardware and not got the site up at Spade Adam ready and so forth, a lot of the work was being done at Westcott, and that meant that that we were doing work for them and their engineers, and we produced data. And Alan Bond would come down from time to time with a group of young ladies who did some of the data reduction. Basically, when we got records, you have to read them, and long before the system was automated, you needed somebody to read records, put it on a tape, put it in the computer, and so forth. So he used to have a little harem of and Alan used to come down looking after them. He was sort of my level of engineer, I suppose, in there. And Alan and I hit it off immediately. We were both space cadets. We talked about all sorts of things. Alan and I have never worked for the same company at the same time, but our histories have gone down over the years with one thing or another. That we've tended to work together, and in fact, I think the last time I saw him, he had an idea, and I said we ought to be careful about this because the last time we had a conversation like this, it took 10 years to get out of it. Yes, Alan is very influential. We worked on Eldo. We worked on subsequent thing that we did on spacecraft propulsion. We invented HOTOL together. We did Project Daedalus together. Yes, there was a lot of things, crazy things that we did along the way.
Yeah, I mean, it can take another half day to talk about that. And I mean, we talked about, in audio interview, we talked about Daedalus and the other stuff. And so, were there any other people there that sort of spring to mind from?
Well, I mean, the team there was. I suppose it's to some extent assembled over the years because I was a late comer into the things. Andy Jeffs was the number 2, who was a good site engineer, sorting things out and so forth. We had Trevor Horton, who did all the work on liquid hydrogen. Spent a lot of time over in his own little building doing things, but trying to remember when I was doing the liquid hydrogen work on storage, there was a guy, I'm trying to remember his name, John something or other, who was kind of my technical assistant on that. Now he was, it wasn't a degree man, he was an HND, had lots of practical experience in doing things, was a good experimental officer, that's what they called them in those days, who kept me on the straight and narrow when I didn't do things properly. But had a very practical approach to doing experimental equipment. And the story I remember there, we went across, I said that when we were working on the liquid hydrogen tank, the people at Stevenage were doing it, so we used to go across there and say what we wanted, and have difficulty because they were working in inches and I was working in meters, and so forth. But on this particular, one of the things was the hydrogen tank. We put a Christmas tree sort of structure in the middle of this that had all the instrumentation on it, and we had to explain to their drawing office what we wanted. We wanted this thing with things sticking off it, and they asked, their drawing manager said, and why is it, we've given a little drawing, and he said, why is it that size? And John said, well, what happened was I went down to the workshop and looked for something about the right size and then found out how big it was. And that was typical, that we would stick rigs together with lasso tape and so forth.
That's interesting, actually, because what was the sort of working relationship between you and people like Rolls-Royce and so on? I mean, you were fabricating stuff, yes, there, but you weren't building complete engines, were you?
No, if it was... well, people would manufacture things for us. Some of it was done at Westcott. One of the things that we did, one of the things in order to test injectors and so forth, was we didn't build a complete thrust chamber. It was basically a large block of copper machined out with the right sort of thing and the nozzle at the end, that had thermocouples into the injector at one end, and you could fire that for a couple of seconds, no longer, and get a firing record before it got too hot and started melting. And you could also measure the heat transfer, which was what I was interested in, by working out how fast the temperature was rising in this block of copper. So we did it on this dumb engine to develop injectors and so forth for them. To build anything that was going, and that was basically done in the workshop at Westcott. To build more complicated things, then that was we were supposed to give it out to industry and so forth. The eventual engine that came out of this was basically put together at Anstey. The hydrogen tank and so forth was put together at Stevenage. But we got involved. We worked together a lot of the time. But looking after the industrial side was something you gave out to people. But you need to know about a lot of this.
Sorry?
You needed to know about a lot of this thing. When we were building the tank, for instance, I got to see how it was put together and what the things were, so we could identify any of the problems that. So I went along to somewhere in the West Midlands that was creating the dome for the tank, and watching. I've still got pictures of that somewhere, and so forth. The people who actually manufactured the dome for the tank spent most of their time building pots and pans, I think, but they had the expertise. Yeah.
I mean, are there any particular tests or events or occasions which spring to mind from your time at Westcott? Any tests that went spectacularly wrong? Or, tests that went spectacularly successful?
We can do. It actually, I probably remember a bit more of those later in my career, because this thing came to a halt in 1970, and I moved off liquid engines to solid motors at that stage. And when solid motors go, they tend to go spectacular. Well, yes, it's quite interesting. Because the liquid hydrogen was relatively quiet. We used to stand in the field watching it without having put air defenders and so forth on. Now, in the 1970s, when I was looking after solid motors, and I was after I got married to Elizabeth, whose father was a farmer living out at Bicester. And if we go down there for a meal, so forth, he would often say to me, "What did you fire last week? It was noisy." And I would say, "I didn't remember anything." You didn't hear the firing except when it was your motor, not somebody else's motor, or when it went bang. So, I was, for the period there, I had the firing sights under my control, but I didn't take any notice of that until one went bang, and you'd hear that. And it wasn't that it was noisy, it was that it went wrong. You got acclimatised to that. But one of the jobs I did then, after I got to was transferred to solids, was question about if you get if the motor gets cold, it can fail because it's too cold. And we did some work. My boss at the time managed to wreck one of the firing sites by having one of the things that he basically made a motor that wasn't supposed to blow up, and it did. All that happens is you make it stronger and it's a bigger explosion. And we decided we needed to find out about this, and we had a series motor we were testing for Huntings at the time. So we, rather than wreck another firing site, we actually took a number of these motors down to a place at Southend, Potton Island, where they had a large open space we could do with, and built a protected stand, as it were, out of Pendine blocks, which are big concrete blocks, about 2 meters by 1 meter by 1 meter. And you stack these on top of it, and you can then withstand some explosions. And we took the motor, rather than firing it sideways, we stood it head into the ground, firing straight up. So we didn't have to worry about it getting free, as it were. And we fired these at temperatures where we thought getting close to this. And eventually got to the point at which we got a low temperature failure. And yes, the blocks were moved. There was very little left afterwards of the girders and so forth we used to. The really funny thing about that, I've still got the picture, is that the motor had a big heavy nozzle which is sort of sitting at the top of this. Afterwards, this was sitting about a couple of metres away from the pharynx. It had gone straight up it. I don't know how high, and down again, landing, making a hole in the ground about 2 metres away. Yeah, that was interesting, and it's this, and we kind of knew what was going on at that stage. But it was a rule of mine afterwards when I got to be in charge of motor design and so forth, that you worried about how a motor failed, and in fact you made a motor so you knew how it was going to fail. And I have a little funny story about this, that the research division, who were interested in what you made nozzles out of and so forth, trying to develop them, and they wanted to have a sort of experimental motor where they could put different nozzles in, and they got something they could work, but they had to come to me as designers to sign it off. And I looked at their motor. The solid motor used to fire sideways, and looked at their motor, and I said, "Yeah, that's okay, but can you take the end next to the nozzle and cut a groove all the way around the motor at that point?" And I'm trying to remember his name. He said, "That'll make it weaker." And I said, "Yes, but now I know where it will fail." And he went, went off and did it. And about 6 months later, he turned to me, "You know you did that?" I said, "Yeah." He said, yes, it failed. It's not going to fail, this motor, but it was going to at some point, and rather than destroy the firing side, it had just blown the nozzle off.
Did you see the test they did with an SRB a few weeks ago? And they managed to blow the nozzle off of that.
Yes.
You think to yourself, blimey, what they've been firing those 40 odd years now.
Yeah.
Thought that was, I mean, I think they're sort of enlarging them for SLS.
Yes, I mean, I haven't seen that, but as I say, if you're sensible, and I think most of us have been in the business some time, get to know this, that you design it so you know when it's going to fail. One of the things, the reason that Ken destroyed a firing site by making it too hot was that what that does is it shatters the charge, and you get a big, and it's big. You basically generate an explosion. Why? I'm having a bit of trouble with my names now. Why the guy from research, whose name I've totally wrong, survived it, was that one way of extinguishing a rocket motor is to suddenly increase the nozzle size. So if you blow the nozzle off, suddenly the pressure drops, and that pressure drop effectively blows out the thing, and you wind up with an intact motor that with unburned charge in it and so forth. Fortunately, we learned that on a small scale before we tried to do it on a big scale. But yeah.
Well, I mean, I'm always interested. Were there sort of friendly rivalries between the liquid guys and the solid guys?
Well, no, because there were different customers basically, but there was always a worry when I was in liquids, that solids were going to poach people's, because they were seen as lower priority than the liquids. The solid people had military things they needed to do. And of course, what eventually happened was exactly that, because in 1970, when the work on liquid hydrogen disappeared, and we were looking at other things, but there wasn't a lot of things on liquid engines there, and they had problems in the solid motor division, excuse me, and the solid, and so the director said, "We'll find somebody from liquids," and the lot fell on me, and I was told, "Can you go and help them out for 6 months?" And 10 years later, that was, which is why I ran into solids.
This is a bit of a diversion, really, but I mean, a lot of the people that were there seem to have been members of the BIS.
There was a lot, yes. I mean, it was an area where...
Can I get you to say that? A lot of the people that I worked with were members of the BIS.
The people who were interested in rockets were interested in space flight, I think, and therefore a lot of people were there. The group I worked with, I think a lot of them were. Barry Ricketson was on the council for a while when I was first there, and eventually sort of passed the job to me. So, which is why I got involved in. I was already a member of the BAS, but I got involved with the workings of the BAS about that time. If you showed any signs of being interested, you would recruited, as it were. Yeah.
Yeah, because I mean, you yourself were president of the BIS.
Yes.
John Harlow was president of the BIS.
Yeah.
I'm trying to think if there are any other staff members from who became not off the top of my
members
head.
on council.
Who became president? It doesn't
No,
matter.
I mean, yes. If you go back far enough, yes.
Yes.
Yeah. If I went.
Oh, because I'm forgetting Ralph Smith.
Yeah.
R.A. Smith.
Yeah.
Was president as well, wasn't he?
Yes. And Ralph Smith worked at Westcott for a year or so, and I think that he didn't like working with the military, and a lot of it was that sense. But he did work there in the drawing office on real rockets, and in fact, on his own ideas. And in fact, I discovered the drawing he'd done of the multi-stage launch vehicle, the winged launch vehicle that he did in 1950s, on an old die-line print in the and more or less rescued that, and in fact, when I discovered it, it was the time. It was at a time when there weren't going to be die-line prints any longer, and we got copies of it made by on the machine that was going out of business, as it were.
What was the security like at Westcott? Because obviously everybody knew what was going on there, but But as far as security, I mean, when you turned up there, were you constantly being surveilled?
Yes, you signed the Official Secrets Act and so forth, and there would be. Yes, when you got particular projects, that came up. In the days when it was an underground launcher, that was classified secret and so forth. And later on, Cheveline made a lot of things about security as well.
Did you actually get involved in Cheveline?
No.
No.
I don't know when. I think a lot of the big recruitment was actually after 1980. Get these decades right here. When I moved off to Waltham Abbey, there's a story there as well. But while it was developing, the solid motor design group got involved quite early, but that was Stan Green. Basically, at that point, it must have happened. I'm trying to think where it all went together, but because it could have been as early as 1975 that they started. I seem to remember Stan making a comment that that when they started this, he'd done a quick, how much effort is it going to take? Oh, about a man and a half. Another underestimate.
And that became sort of an absolute.
That became
major.
almost everything.
Yeah.
But at the time that it was sort of growing, we're nominally part of the same group in the solid motors division. This was the design. It was design and post design services group, and all these new things that Stan was going off to. Stan and Annie Tatum, I can remember her, worked together and went off and did their thing, and I did everything else basically. So I was doing everything that wasn't Cheveline for a period there, because I got to be promoted to be again, look at my notes. I got to be head of design in 1975.
Can you just say that without you say that
Yeah.
for me, just so that you're not,
Right.
you know.
Yeah, I got to be made head of design and got to be PSO in 1975. And Ken Silman got the name, who'd been my boss, became head of the solid motors division at that time. And so I was looking after all the design that wasn't Cheveline at that point. I had it was not obvious where this was going. Let me put it this way. Because in the scientific civil service, having got to principal scientific officer, further promotion was pretty well, not entirely true, but was was a designated post. That is, you applied for a particular job and got it or didn't got it, and that was your promotion. And it wasn't clear in the late 1970s where my next position up in the career path was, because it was a fairly small group, and you knew what was available and who was likely to go and whatever. In fact, not only was I aware of this, but other people in the hierarchy were aware of this, and one of them said the Australian Department of Science, whatever, are looking for somebody. Would you be interested in this? That sounded interesting, let's put it that way, and it would have given me a promotion. And I didn't see a promotion coming up anywhere in the foreseeable future otherwise. And so I went through a thing with the Australians about taking a job out at Adelaide or Woomera, which was no greater problem from that point of view, except that when they offered me a job, my wife said, "I'm not going." I don't want to go to. I mean, she afterwards, she said, "I thought you weren't going to get the job, and therefore I didn't have to make a fuss." That looked like the end of the road to me. Okay, but we had, I said, we had a young child. At that stage, so okay, but soon after that had happened, and it was probably as a consequence of that particular thing, the Barry Newman, who was then director of Westcott and Waltham Abbey, because they'd put the two together, called me to his office and said, "Are you applying for the P2 position at Waltham Abbey?" And I said, "It's a chemist job." And he said, "Are you applying for the..." And I said, "Yes, sir." So I then went off to Waltham Abbey in 1970 to take over the P2 branch at Waltham Abbey, which again wasn't really what I wanted, but it was a route up. And so I then had 2 years of commuting to Waltham Abbey. What then happened, it's one of these things, I don't know if I said, in that position, and it was an interesting job because I was an engineer bossing a gang of chemists. So you had to learn management techniques, which is, I don't understand a word of this. How do I work out the right thing to do? Yes, you can do it, but it involves you listening rather than thinking. And once again, it's interesting that that management isn't telling people what to do. It's sometimes just listening. Sometimes it's just pushing people in the right direction. It's much better if it works that way. And people who do it for the power generally get it wrong. But in that position, I used to get House of Commons questions past my desk and so forth, and things that were relevant to this. And got used to these. Most of them were you passed them on and didn't do anything. And one day, one of these passed was about rationalising it to close down some of the sites, like Waltham Abbey's south site, which is where I was. and reducing the amount. And I looked at it and said, that's going to happen. Now, the problem with the senior principal positions in the scientific is you've got to have a designated post. There's not 100% true, but it was true. And if that happens and you lose the post, you get sent where they sent you, not where you've chosen to go. Probably the situation there was I was going to find myself up in Glasgow at the explosive plants up there, and Elizabeth didn't like Australia. She wasn't going to like that either. And fairly soon after that, while I was still wondering, what do I do now? The BIS had a trip round Stevenage, which at that time was starting to pick up space work. And we went round, and I decided I'd like to see this, and so I took the day off and went for the tour with the BIS, which had Charles Martin running it, again somebody in the BIS, and towards the end of this I talked to him. I said, do you have any good jobs going here? That was my job interview for Stevenage.
What did the work involve at Stevenage?
Well, at that stage, there was Space Lab work, and there was the beginnings of space station thinking. There was starting direct transmission communication satellites and so forth, and so there was the Stevenage was involved in space work when the UK wasn't particularly doing it, because Hawker Siddeley, as they were at that time, had an interest in developing this, and this is in Westcott. But to tell the thing, it gave me slight embarrassment because I said that was my job, and that's basically, they said yes, but they're not actually physically offered me a job. But but I was in Waltham Abbey, as it was then. I was a member of a thing called the Tetrapartite Technical Collaboration Committee, which was basically us talking to the people we trusted, which was the Americans, the Australians, and it was us talking to the Canadians, the Australians, the US Air Force, the US Navy, and occasionally the US Army. The way it worked exactly like that. It were like, as the US people were entirely separate from one another, and they only talked to one another when they talked to us, as it were. And the next big meeting that I was going to be sent on was out in Australia. And I worked out when this was going to happen. It was going to happen about the time I would change job, but I couldn't tell. And I actually went to Barry Newman and said, I think you ought to find somebody else to go out to Australia, because I'm not sure. And about a fortnight later I said, yes, I'm going. Now and when I got into Stevenage, the first day at Stevenage, before they had found me an office, Charles Martin gave me a sheaf of paper about that thing, and he said, "You ought to read this because you're in Toulouse tomorrow." It was a sad change in working conditions. But that meeting was the group, the industrial group meeting on planning for the space station. That was the beginnings of it. Nobody knew what was going on, what would happen or whatever. It was all basically round the group that had worked on Space Lab. And
this was ESA, was it?
This was ESA, yes.
This was with ESA.
But out of that group and those meetings, which I managed to hold my own out because I'd been in the BIS rather than anything else, we eventually got the UK involved in the Polar Platform, which turned into MVSat. So that was worth about 1.8 billion things out of that. Started with that particular meeting. This is in Westcott again. And of course, the other thing that happened to me, it was while I was at Westcott, but was HOTOL, which again started from these things. It started because of the BIS that they had a number of meetings of future launch systems, and they had one where up in London, which was basically to do with what would happen after Ariane 4, and had somebody from CNES came across and opened up their ideas about Ariane 5, liquid hydrogen. Liquid hydrogen work hadn't finished. A lot of it was stuff that I was really familiar with on a somewhat bigger scale, with two big solids on one side and the Hermes space plane on the top of it. I went up to this meeting and sat next to Alan Bond as a thing, and Alan and I watched this presentation, which the French were very proud of, and he said, "It's dinosaur, Type 3 dinosaur all over again." There must be a better way of getting into space than just following the Americans all the time. And so we went away and individually idly wondered about this thing, and the BIS had run internal things and so forth. And about June, Alan knows the date and I don't. When I was at Westcott, when I was at Waltham Abbey, Alan rang me one day and asked me a question about, and it wasn't really about this. He was worried. He wanted to know about liquid ozone as a propellant, and I said no, it blows up, basically. But we talked on the phone about our ideas, because I'd sort of been wondering how much you needed to do to get a single-stage orbit vehicle to work, and Alan had been worrying about what sort of engine you'd need to make a and I said, it looks like we have we've been running on parallel things. We ought to get together and talk. And eventually, out of this, about 2 days before I left Stevenage, before I left Waltham Abbey, went to Stevenage. In fact, it was the leftover leave that I had to take before I left. We had a meeting in Alan's office, who was working at Culham at the time, with John Scott Squared and David, somebody else from from Amsterdam, and we put together this idea that turned into Hotel. So basically I walked into Stevenage with an idea that I wonder whether anybody would take an interest in. And the answer was people were interested in what we were doing, and that was the next 10 years of my life again.
So who actually did the talk a bit about who did that initial development work on the heat exchangers and so on? Prior to it getting at that stage cancelled.
No, I basically at that first meeting, John Scott. The question we had when Alan did his thing was, you've got a heat exchanger, you can't build the heat exchanger. This happened in part after I got to Stevenage, because we had another meeting, and John produced. Here's an example. Demonstrated he could produce this sort of thing, that it wasn't impossible, that we could build something. There were all sorts of issues. I mean, all sorts of little things tend to walk out of the woodwork. Since I was interested in what the vehicle would look like rather than what the engine would look like, I had my own ideas, but it involved bits of aerodynamics and so forth that I couldn't quite cope with. I was at Stevenage in my office, and yes, I said that I can't remember the names very well. It'll come to me. But I got a call from Bristol, who wanted to know about, I can't even remember what they wanted to know about, why I got called, but when I'd had a call with him, I said, you're one of the people who could probably help me about supersonic lift drag and so forth. And so he invited me down there, and I met the group at the ex-Concorde group at Stevenage, who told me about how to design the basic shape of the Hotel vehicle, and that's why they got involved in that. And that was an out of the blue phone call that was made to me, not because they knew I was doing that, it was because I was doing something else entirely. Possibly, I can't remember what the subject was. Frank Crowfoot, that's the guy who rang me, I can't remember what it was. It could even have been some leftover that I'd had from my Westcott days, that why I got called.
Just to clarify,
yeah.
Alan was working for British Aerospace.
Alan was working for...
And you were working for...
No, I think at that point he was working for the jet team at Culham. Certainly had an office at Culham.
Right, okay. So...
I said we never worked for the same company at the same time. I'm
just thinking...
We both worked for British Aerospace, but I don't think they ever overlapped.
The initial work he did...
Yes.
On heat exchange. I mean,
yes.
They did actually sort of...
Was in the time it wasn't supposed to have. Working
so who actually did that? Was British Aerospace? Was it British Aerospace who actually did that initial design work? And
no, the initial design work, the initial concept for the engine was Alan working with John Scott.
Yeah. Alan
at Culham and John Scott at Anstey.
Right.
Not as any official thing. It was basically spare time activity. The airframe part of it was me trying to put something together and then discovering the Concorde group at Bristol, who tell me what it really should look like, and so forth, and the another phone call out of the blue that was involved in this was Peter Conchie, who at that point was at British Aerospace Hatfield, and he rang me about something to do with solid motors, I'm pretty sure. But he said, and I'll be coming to look after you guys in a month's time, because I'm coming to be director of future projects and sales. And he talked with Alan and knew that this idea had, but he came sort of prepared to act as frontman for Hotel at that stage. So we were starting to produce an entirely unfunded, unofficial team there. Peter got BNSC to put some exploratory money into what future launch vehicle should be, not Hotel, and we did a sort of little study on it, whose answer was going to be, and you need Hotel. So there was that was the first time I actually had somebody paying me to do this, this work, and started to put the team together. That got the interest further up the hierarchy of British Aerospace, and that started 82. In that, according to this, it says that between 82 and 85, basically, my principal jobs were managing the Phase B polar platform activity, which eventually turned into MVSAT, which got given to Bristol Space, doing the initial work on the liquid combined propulsion system for the Eurostar communications satellite, which was going to be the big communication satellite still there, and doing this early launch vehicle activity. The 85 was when it got in front of the Admiral, Sir Raymond Ligo, who said this is really what we ought to be doing, and was quite enthusiastic about it. And the minister, and it basically got in front of the minister because of the space station, because we've been doing studies for ESA on what happens after Space Lab, space station, what part do we take in, what the Americans are proposing, and so forth. And so I've been fairly active in those groups doing things for ESA. The minister who's what's his? It's in the book anyway. Read Interplanetary 2. It's in there. Said we're going to have a national debate on what we do. I'd heard this term, national debate, and not knowing what it was. It was actually a big meeting up at the Royal Aeronautical Society, which was organised to the point at which we knew what the answer was. No, it wasn't said in as many things, but it was quite clear that by that time we knew what we wanted the UK to do. We had the support of the environmental people on the polar platform idea, and that was, we weren't going to get a manned space flight out of it. I remember that guy from Logica, one of the directors of Logica, did a long, serious talk, presentation on the issues that you needed to do to answer this question, which basically went down like a lead balloon. And I was put on after him to talk about the polar platform. And I had a big picture of the concept that was nothing like what it eventually turned out to be, and said, this is what we want to do. And that was the answer, and that was it. But he got it in front, got the Admiral and myself and Peter in front of the Minister, and who was actually more interested in HOTOL, as was the Admiral, than the polar platform. That was we knew what that was happening. And so that was the point, that was the famous meeting at which we need a programme of this, and the Admiral said, I'm prepared to put £1 million of my money on, what are you prepared to do? And that started HOTOL seriously. And because the Admiral then had to find the money that we wanted, the project got, basically the money was at Wharton, the people at Wharton got involved, and the whole thing started properly.
Excellent. Yeah. I'm just going to take a little break from that.
Yeah.
Do you want another cup of coffee?
I need.
It's really just the question, looking back.
Okay.
For that over the last 70 years or whatever it is of space.
Right. Are you ruling?
I am running.
Okay. Yeah. The rule that Charles Martin gave me when I first went to Stevenage was space is politics, economics and engineering in that order. You may be in here because you think the engineering is interesting, but you've got the other two things will get in the way. That's been true quite a lot along the way. We do things because we value them, and the engineers value the engineering or the idea of flying to the moon or whatever. That has been what the people who want to build spacecraft and rockets and so forth are in it for. But it's not an easy job. It involves a lot of people and that gets you involved in the economics end, and half the people who are working in it are in for the economics and not for the engineering. And in particular, finding the money to pay them, the customer is not interested in flying to the moon. They're interested in something else, which is the politics end of the thing. And in particular, in this early stages of so forth, space has been different to some extent from, let's say, Antarctic exploration or flight or whatever, that that it's been political from the word go. To some extent, because it has a lot of politically attractive aspects to it. Kennedy's "we must go to the moon to beat the Russians" was a typical example of that. It's the one view graph in front of the president says we must beat the Russians, not is useful for learning about our place in the universe or whatever. It's we must beat the Russians. Unfortunately, that doesn't make it cheaper either. And so there's not a lot of different things get done. They get done and get abandoned for political reasons, even though the engineers and the visionaries see the logical way of going through it. It won't get done in the logical way because it get done one bit at a time, and each bit is not fitting the jigsaw puzzle, it's fitting a different jigsaw puzzle. It's changed because one of the things that seems to have changed things, actually, is the internet and the software business, because it produces people like Elon Musk who've got a lot of money who can do their own thing independent of the politics. So it actually starts to take politics out of the thing. It doesn't, because as we've seen, that much money is political regardless. But it means that once again, one man's idea tends to dominate, and there's not a lot of room for evolution there in what happens. The doing things, but in order for us to get the sort of vision that we had, means that it's got to stop being one source thing and become something that different things get done in different ways, in little bits, and some of that is happening. It's happening in the satellite business because all of a sudden relatively poor people can afford to build a satellite. I suppose that starts with satellites and Sweeting doing their own thing and finding ways into the system, and all of a sudden we've got and so millions of microsatellites was not in the plan, and to some extent may be a problem later on things, but it happens because all of a sudden you're not in the big politics area. It's made it possible, but that was almost inevitable. It's almost, I was going to say you can kind of see some of this if you look